So in this particular discussion, we want to talk about the idea of independence and mutual exclusivity of events. So let's just jump in right away. So two events, A and B, are known to be statistically independent if they satisfy this equation. All right, so P of A intersect B is equal to P of A times P of B. P of A intersect B is equal to P of A times P of B, or vice versa. If you realize that P of A times P of B, and you verify independently that separately that that's exactly P of A intersect B, then straight away you can conclude that A and B are statistically independent. Okay, let's just do a quick numerical check first, right? Using this example. So what is P of A? That's five balls divided by 10. Yeah, so 5 out of 10. Let's multiply that by P of B. So P of B, that's 2 balls divided by 10. Now we enjoy the counting, right? Because that's very useful. So 2 out of 10, and we multiply, we get 1 out of 10. Let's check whether P of A intersect B is also 1 out of 10. So P of A intersect B, that's 1 ball out of 10 balls. So by counting, straight away we verify it is 1 out of 10, right? And they are exactly the same. What can we say? We conclude, therefore, that events A and B are statistically independent. Is that okay? So what about the other way around? Because this arrow goes both ways. That means if we check that this is true, right, then it is statistically independent, right? Okay, so this is therefore our conclusion. What about this equation here? All right. Well, it is easy to check that if we bring P of A down to the denominator, so we get P of A intersect B divided by P of A. Just give me a bit of a few seconds to write this very carefully. All right, then this term is gone, and straight away we arrive at P of B is equal to P of A intersect B over P of A. But that is the definition of P of B given A, right? So that's why we very easily can arrive at this. Yeah. In fact, you might ask, why do we bring P of A down? Can't I bring P of B down? Yes, you can. If you do that, then you get P of A is equal to P of A intersect. Given that B has occurred. Okay. So you see that they are these are consequential results. The moment the question, the exercise question, homework question, the exam question tells you that A and B are independent. Okay, that means in other words, the moment we get this state to be true, that means the exercise question declares to you that A and B are known to be independent. Now, when I was solving questions last time when I was learning this stuff, I completely just, oh, okay, fine, I just read the word independent as an English word telling me, okay, warning, warning, they are independent. Okay, then what do I do? I have no idea. And little did I realize that independence actually is giving us a whole hoard loads of treasure that we can work on to solve the problems. Okay, later on in hypothesis testing and in many useful statistical operations, you find that independence is a very common and useful and strong assumptions that will make calculations formulas easier, just like here. Yeah. So if we know P of A, if we know P of B, and if calculating A intersect B is a difficult chore, doesn't matter. Just times them together if we know that they are independent. Right. But if we don't know, then when you multiply them together, it may or may not be exactly P of A intersect B. All right. So we then have to manually go and count A intersect B divided by count of all, and then we to independently arrive at the answer. So independence is a very powerful assumption, and it gives us these three equations to play with immediately. All right, just remember just now, if we can flip back the slide, that these three lines, they are golden formula. They work no matter whether A and B are independent or not. But these three lines, however, they only work when it is known that A and B are independent. So very, very important word here. Are A and B statistically independent? Uh, this will rely on the question to tell us. If the question says so, very, very important. Quickly write down these three lines. Okay, because they are treasures that are given to you. They are invisible. And you should make them visible because you don't know what other questions come next. And seeing them written out in the context of the question helps you to, arms you with more tools to be ready for anything that comes after. And then you can solve them more readily, right? Okay, let's take a moment to understand the right hand side here, right? The left hand side is the definition. The right hand side here, what does it mean? It says the probability of an event happening, all right, given that another event has happened. So P of B given A is like as if you didn't tell me that A has happened. Remember the COVID-19 example I gave, right? So what's the probability of a person getting COVID-19 positive, testing positive for COVID-19? P of B, right? What's the probability of a person testing COVID-19 positive given that, all right, given that he has just gone to toilet? Well, probably the same. Yeah. So we don't need to be scientists to say that, right? I mean, it's common sense enough, right? So if you really ask me to write down, I would just say, well, they're the same. And that's the reason why in this case, going to toilet, I mean, let's assume it's a clean, empty toilet, right? No one has used before and has gone in before. So clean, empty toilet, and COVID-19 positive, well, not really related, right? So independent, right? Whether the person has gone to toilet or not, doesn't affect, yeah, the positivity of testing for COVID-19. So in that sense, we can kind of use a bit of common sense to understand this logic here. But of course, here what we're writing is much more mathematical. So we're going to verify this using the numbers. Okay, so when we check that the numbers agree, P of A intersects B is indeed P of A times P of B, we conclude that the events are statistically independent. Okay, that is okay. That is okay. But can it be that I purposely move the balls around? You know, it's not really independent, but I configure them to be so, to make the numbers agree, right? So yeah, it is possible, right? So it is often important to just uh, qualify the independence as statistically independent. And that does not necessarily mean that they are totally void of influencing each other. They are totally not affecting the behavior of one another. In fact, in business, uh, seldom do we have businesses not reacting to each other, right? Competitors react to each other's response. Consumers and suppliers react to each other's demand and pricing and all that. So if business is selling something and somehow there's no response from the consumers, it will do marketing to promote more demand for its products to make some dependence, right? So it is very hard to observe complete lack of independence. Very hard just means almost impossible. But then, this still holds if you say that it is statistically independent. That means the numbers all kind of coincidentally agree with each other for unknown reasons, right? So we can still say it is statistically independent, even though in real life, maybe there are some very invisible forces that somehow, make all the balls align in such a way that the fractions agree with each other. Yeah, so we won't know, but by and large, when you're solving problems in exercises, homeworks, exams, we would just cut short it to just say independence. assume that A and B are independent, when we actually mean assume that A and B are statistically independent, something like that. All right. Okay. Next idea is about mutual exclusivity. So if A and B, again, if the question tells you if A and B are mutually exclusive events, so how do I think about that? Yeah, one easier way to think about this rather elusive description is that the two circles don't intersect. Okay, the balls are either in A or in B. They cannot be both, like in the yellow ball case. So think of them as, you know, two segments that are not touching each other. So A and B are mutually exclusive events. Yeah. So given that, that means this is the condition that is given to us. This is a fact that is known to us. What can we say about their independence? Then we confirm and we can clearly say that A and B are not independent. One qualitative way to think about that is, well, if you tell me this ball here on top here is in A, all right, what's the probability that it's in B? Well, of course, I know it won't be in B, right? So I say for sure it's 0. So they're kind of dependent, right? If you tell me it is in A, then I confirm no that it is not in B, and vice versa. So that's the kind of qualitative way for us to think about it. But does it agree with our definition of statistical independence? Let's check. P of A intersect B. Okay, now you see, if you think directly with probability, it's very hard to think about it. That's what you mean by P of A intersect B here, right? So if you think about count of number of balls that are in both A and B, well, there's no overlap, so 0. Then 0 divided by anything is 0. Then it's very easy to conclude that it is 0. And then we check. P of A, clearly it is 4 out of 10. P of B, it is 2 out of 10. So it's non-zero. So left-hand side is 0. Right-hand side is never 0. What can we say? Well, we say that they are not statistically independent, right? So yes, it agrees with our definition just as well. Fortunately, isn't it? Because otherwise it would be very strange to have a common sense logic telling us it is not independent, but then the definition tells us it may be independent. Oh no, so no. Fortunately, that's not the case. So they gel very well. And what you need to be very careful of is mutual exclusivity. All right, when this word appears in the question, pay attention. Confirm A intersect B, the probability of that is not P of A times P of B. Confirm it is not. Yeah, so that is what it is trying to tell you. So fortunately, I seldom see questions about mutual exclusivity. So maybe when I set questions next, I should do that. But if that happens, you need to be aware of the implications. All right. And much more importantly, let me just emphasize it again. Whenever the question says A and B are known to be independent, all right, then quickly write down these 3 additional understandings about that particular question. So 2 important keywords here: independent and mutual exclusivity. Right? Be very, very aware of that.